Video is about first row D block elements. The keyword in the question is to determine the magnetic property of these three species, and the concept is understanding magnetic property of transition metals. And so magnetic property of a transition metal can occur in two types. So we have diamagnetic and paramagnetic. So diamagnetic doesn't have magnetic property, where paramagnetic does, because diamagnetic only has paired electrons, and conversely, paramagnetic have unpaired electrons. So if we were to draw out the unpaired electrons in its orbital, it would look something like this. And the unpaired electrons are able to have space to spin, which allows it to behave like a magnet and attract external magnetic force. But if we were to have another electron in its orbit occupying the same orbital, it won't have the space to spin, therefore it cannot act as a magnet. So let's take a look at iron as an example. So if we were to write out its condensed electron configuration, we would have something looking like this. We only need to focus on the d orbital, so let's look at 3d6 and draw it out. So we can see when we draw it out, there are 4 unpaired electrons. And so the unpaired electron does have the space to spin and behave like a magnet. Therefore, iron is paramagnetic. So let's go back to our question and look at zinc atom first. So writing out its condensed electron configuration, we can see that the d orbital has 3d10. And this is a full d orbital, which means there are no unpaired electrons. And so zinc is diamagnetic. And we can look at copper ion next. And writing out its condensed electron configuration, we can see it also have 3d10, which we can write the same explanation and answer for copper as zinc. Let's move on to iron ion. We have 3d5 in the d orbital, and so if we to draw that out, we can see there is 5 unpaired electrons, which means iron is paramagnetic. And that is our final answer for this question.